In this video, we're going to look at CRA models for integer subtraction reasoning. So we're going to have three different cases. The concrete model is going to be our two color counters with the 10 frames, representation will be number lines, and then abstract will kind of move through the steps of the concrete model using the symbols and numbers. So the first ones we have -5, just means you have 5 red counters as opposed to 5 yellow counters. So you have 5 negative, and we want to, or 5 negative counters. We want to take away or subtract 3 red counters because we want to take away 3 negative counters as well. So again, here we're conceptualizing subtraction as taking away. So since we have 3 negative counters that we can take away, we can just take away the -3, the 3 negative counters. So then what we're left with is 2 red counters or 2 negative counters or -2. So that's the concrete model, representational model. We're starting at -5. Again, normally when we're subtracting or taking away, that means we're moving to the left on the number line. But here we want to subtract the opposite of 3. So if we were subtracting 3, we'd move to the left. We want to subtract the opposite of 3, so we're going to move in the opposite direction. Those 3 units to leave us at -2. Okay. And then the abstract model, again, numbers and symbols. Essentially what we're doing in, this is especially easy to see in the concrete model, is when we're taking -5 and we're subtracting -3. Essentially what we're kind of doing is decomposing that -5 and thinking of that into two different pieces. So we're essentially thinking of that as -2 plus -3. All right, so kind of those two portions, and then we still have this minus -3 from that right half of the equation. And then what we're essentially doing here is if we have -3 and we want to take that away, anything, right? It doesn't matter what these numbers are. If we have that quantity and we subtract that same quantity away, what we'll be left with is 0. So then what we're just left with is that -2. Okay, so that's our first case. We had -5 minus a -3. So that's the easiest to conceptualize in the concrete model, which is why I started with that one. I'll move to a different example. So here we're starting with a positive amount and then we're subtracting a negative amount. So we're still having that subtracting a negative type of scenario, but here we're starting with a positive amount. So we'll start with our concrete model. So we're starting with 5 yellow counters, so +5. And again, we want to take away 3 red counters because we want to take away the opposite, right? The opposite side. So in this scenario, we don't have any negative counters we can take away. So kind of how we can think of this is by adding, we need to add in some 0 pairs so that we can actually remove 3 red counters or 3 negative counters. So what I mean by adding in 0 pairs is we're adding in pairs of counters where their sum is equal to 0. Okay, so we're going to add that to this quantity. And the reason we can do that is because we're not changing the overall quantity. Since we're adding 0, we can always add 0. We'll still get that original value. That's that identity property of addition. Okay. All right, so I've added 1 0 pair. So it looks like I'm changing the quantity, but again, these, if we were to combine these, this +1 and -1, that's equal to 0. So we still really just have a value of 5 shown here. Okay. So we're adding then a second 0 pair, and then a third 0 pair. So obviously the reason why I'm adding 3 0 pairs is because we want to take away 3 red counters. Now in this quantity we have 3 red counters we can take away, so now we can actually go ahead and do that subtraction. We've taken away our 3 red counters. What are we left with? We have 8 yellow counters or 8 positive counters, so our difference there is going to be 8, +8. Okay. So this concrete model, we'll look at representational. So, and we're starting at 5. Again, normally if we're subtracting, we're moving to the left. Here we're subtracting the opposite of 3. So if we were subtracting 3, we'd move to the left. We're subtracting the opposite of 3, so we're going to move the opposite direction. So we're going to move 3 units to the right to get up to 8. Okay. And then for our abstract model, so essentially what we did in that concrete model, again, we're kind of thinking of this decomposition in a little bit different way, right? We eventually had 8 yellow counters and 3 red counters. So we decomposed this 5 into 8 plus -3. All right, so that was the 8 yellow counters and then 3 red counters. And then we still needed to subtract away -3 or subtract away those 3 red counters. So again, if we kind of zero in on this area, if we have -3 minus -3, if we have 3 red counters and we take away 3 red counters, right, we can do that and it'll eventually just leave 0 red counters. So then what we're left with is just that +8. Okay, so the second case and then our last case here. So -5 minus 3. So we're starting in a negative. We want to subtract a positive amount. This one looks kind of similar to the previous example, but just kind of the opposite case. So starting with -5, so we're starting with 5 red counters. We need to take away 3 or subtract 3. So since that 3 is positive, we need to take away yellow counters. So since we don't have any, again, we need to add those 0 pairs. So I can add a 0 pair there. Still haven't changed the quantity since I've just added 0. We'll do that 2 more times. Again, the reason we're doing that, adding 3 0 pairs, is because I need to take away 3 yellow counters. Now I have 3, so I'll stop there and I can actually do that subtraction. So now what does that leave me with? That leaves me with 8 red counters or 8 negative counters or -8. Okay. So that's the concrete model. Representational model. Right, this one's a little bit simpler on the number line because we're starting at -5 and we're just going to subtract 3. So we're not subtracting the opposite. So we can just think of this as normal subtraction from the number line perspective. So we're still just moving to the left. Right, moving to the left 3 units. Down to -8. Okay. And then our abstract model is going to look similar to the one we had thought of in the previous example, where we're just thinking of this decomposition in a little bit different way. So, right, we eventually had 8 red counters and 3 yellow counters. So we decomposed this -5 into -8 plus 3. Okay, and then we still needed to subtract that 3, and again, this 3 minus 3 is just going to be equal to 0. So that just leaves us with that -8.